Okay, this is continuing problem number 7, the carbon dioxide absorbent. So we're going to go, we did the skeleton equation, we balanced it. We're going to set up the problem. So let's quickly set up the problem. So on average, an astronaut exhales about 20 moles of carbon dioxide each day. So 20 moles of carbon dioxide is what we know. What volume of water? We're going to need to find water. Okay, so, and it tells us to calculate the grams of water produced first, and then the volume. Okay, so let's figure out, we want to stop at grams of water for a moment. So let's try that. Grams of water is our endpoint. And we're starting with 20 moles of carbon dioxide. 20 moles of CO2. Well, in our equation, what do we see? We see that 1 mole of CO2 gives 1 mole of water. So that should be pretty straightforward. Every 1 mole of carbon dioxide yields 1 mole of water. Not a lot of math to do there. But what about how many grams of water? Well, let's calculate that. 1 mole of water, how many grams are in 1 mole of water? So for water, H2O, we've got 2 times our molecular weight of hydrogen and 1 oxygen. So hydrogen is 2 times 1.0079 and 1 times 15.9994. Probably being a little bit too precise here for our needs. So we've got 2 times 1.0079 plus 1 times 15.999. Okay, so our molecular weight of water, you might remember this from a previous lesson, is 18.015 or 18.02. Either way is fine, grams per mole. Let's just call it 18 grams per mole because we started with a pretty rough number, so we needn't use so many decimals. And now we're in grams of water, and that's exactly what we wanted. Let's just do the math on a calculator here. We have 20 times 18, and we get 360 grams of water produced from the 20 moles of carbon dioxide they exhale. Now, the problem is really asking about the volume of water. And right, so let's go back here, the volume of water. So we did this, we set up the problem, right, put moles on the left and grams of water on the right. Okay, we calculate grams of water produced, and now we're going to do that last piece of using the volume. Well, that's where this piece of information, the density, comes in. Density tells you how much stuff, how much mass per a unit of volume we have. So 360 grams of water. Well, what do we know about water? Water's density is 1 gram, exactly 1 gram of water takes up 1 milliliter of volume. That is the density of water, and that was given in the problem. Right, there are a lot of denser things, but that's the density of water. And so we'll see that dimensional analysis helps us go from grams into milliliters. Okay, and we'll notice we get 360 milliliters of water, right? I'm just multiplying by 1 here, so I don't need to break out the calculator. Okay, and so we have figured out that it gives us less than a bottle of water, right? All the carbon dioxide exhale, if we react it, gives less than 1 bottle of water. That's the end of problem 7.